So cluster sampling, on the other hand, will help us get a sample without creating a sampling frame. Cluster sampling allows us to get a fairly good sample. You know, good is subjective, okay? A good sample, good being about as representative of the population as we can hope for, okay? Allows us to get a good sample without a sampling frame. Okay? And what this requires is that the population is divided into subgroups called clusters. And I should say the entire population is divided into clusters. And it is easy to get a list of all the clusters. It is easy and what we would do is we would randomly select clusters from that list. Okay. And once we select the clusters, perform random sampling. Or survey everyone. Survey everyone in the cluster. So, for example, let's say you wanted to take a survey of people who attend church in Los Angeles. Okay, so you want to. So in this case, the population is everyone who goes to church. Okay, so let's say your population everyone in Los Angeles who goes to church. Okay, and so you want to take a random sample from that. Okay. Well, to do that, you would need a list. Your sampling frame would be everybody who goes to church. That's a difficult sampling frame to obtain. Okay. What's much easier, though, is to get a list of all the churches that exist in LA. Okay. We should be able to do that with the help of the internet and phone books, and we should be able to get a list. Or, you know, even just from the city, I don't know, business office or something. We should be able to get a pretty good list of all the churches that exist in LA. Okay, we might miss some small churches or churches that just started up or something, but it's, so I'm going to write difficult to get a list of everyone. Okay. Easy, or easier, to get a list of all churches. Okay? And so if we have a list of churches, you know, whatever, 100 churches, 100-something churches, or however, I don't know how many churches there are. But let's say we get a list of all the churches, then we can randomly select churches on that list. randomly select churches from that list. And then with, let's say we selected 20 random churches, then we go to each of those 20 churches, and then we can perform random sampling. Maybe we say, do you have a list of everyone who comes to church? Some churches might say yes or no, and then we can select people at random from that list. Okay? So then we perform sampling, or if you want to survey everyone, you can survey everyone. That would be a little bit different, but same idea. Perform sampling on these selected churches. Questions on this? You guys able to read the board okay? Yes?
So the clusters in this case would be the churches.
Yes, the clusters would be the churches, okay? Because our population, which is everyone who goes to church, is divided into clusters, which are the churches. And so we would randomly select clusters, randomly select churches.
The clusters don't necessarily have to be of the same size, right?
Right, okay, so there is going to be a slight bias towards selecting an individual from a smaller cluster, okay? Because the clusters each have an equal chance of being selected, but within a cluster, if you go to a smaller church, you have a higher chance of being selected versus if you attended a giant church. So, you know, these are not, this is not a random sample, but it, you know, a lot of times it'll give you something close to a representative sample, which is our goal. Okay. Anytime you take a sample, if you were to take another sample, you know, moments later, the samples will be different, okay? So every time you take a sample, different, okay? So if I take 100 random people, and then I take another 100 random people, even if the first sample I put back in the population, I'm probably not going to get the exact same group of people, okay? And if the first random sample of 100 people, I had 52 females, if I take another random sample of 100 people, maybe I will get 50 females, okay? So every time we take a random sample, the samples are different, and the amount of variation that we see from sample to sample, that is called sampling error, okay? Yes?
Does that only apply to the cluster sampling, or just?
Oh, no, I'm sorry. This now, okay, now what I'm writing here, it applies to sampling in general, okay? And most of this stuff, we're now reverting back to assuming simple random sampling, okay? And so, pretty much the rest of this course, whenever we talk about a sample, I'll probably say a random sample, and I'm talking about simple random sampling, okay? And again, It's conceptually the most simple sampling method, but perhaps practically the most difficult sampling method, okay? There, let's, okay. And to be honest, you can take an entire course devoted to sampling methods, okay? And you can even dedicate your life to researching and perfecting sampling methods, because it is an important aspect to statistics, okay? And Pew Research is an organization trying to perfect their sampling method, because they do ask questions about opinions and things like that. And if they want to say that this is representative of the U.S. population, their sampling methods need to be high quality, okay? And so that's an organization dedicated to getting high quality samples. And so, we're spending just a few minutes, or maybe more than a few minutes, in our first week of lecture here, but we don't really talk about sampling methods, later on in the course. Okay, we're going to be doing a lot of learning statistical tests and methodologies, but sampling is a critical component to research, and your sampling methods need to be accurate if you're doing any kind of survey-based research or studies. Okay. Yes, the variation we see from sample to sample is known as sampling error. How am I doing on time here? Okay. Why don't we take a 10-minute break here?